Let's try to solve this question here. When a capacitor discharges through a resistor, it loses 40% of its charges in 10 seconds. So they ask you to determine the time constant, and they also ask you to determine the percentage of energy that is left in the capacitor after 10 seconds. So again, if you are talking about charging and discharging a capacitor, the first thing that we should do when we have a question is to identify whether it's a charging circuit or it's a discharging circuit. So if you look at this question, it says a capacitor discharges through a resistor. So it's a very clear indication that this should be a discharging circuit over here. Okay, so this is a discharging circuit. So what information do they give you regarding this discharging circuit? They say that it loses 40% of its charges in 10 seconds. So if we represent it in the form of a graph, right? So this would be a graph of Q against T, because they say charges, right? Okay, so Q against T, we know that for discharging, the amount of charge stored in the capacitor will be decreasing with time. So it will approach 0, but never really touch 0. So it starts with Q maximum, Q naught. Then it say that in 10 seconds, it loses 40% of its charges. So loses 40% of its charges, you can think of it as if you have already dropped by, you already minus by 40%. So if you have already minus by 40%, I believe you are aware that what's left is 60% of the original amount, right? Or the maximum amount. So what's left is 60%, or we can call it as 0.6 Q naught. So that's what's left. So if you check the amount of time it takes to drop until 0.6 Q naught, that's 10 seconds. Okay, so if you put it into equation, right, this is discharging. So Q is equal to Q naught E negative T over tau. So for this case over here, this will be, if you sub in 10 over here, what you get from this equation will be 0.6 Q naught. Okay, that's the idea that they are trying to deliver over here. Okay, so first thing is ask you to determine the time constant of the circuit. Well, I believe you have the necessary information to determine it. If you are thinking of approaching this question using tau is equals to RC, you might be facing some trouble here. Okay, because I don't think you have the resistance, and I don't think you have the capacitance as well. So you definitely cannot approach to determine the time constant using this method. You should resort to the information that is given in the question, which is that the Q discharged and after 10 seconds left with 60% of Q naught. Okay, so Q is equals to Q naught E negative T over tau. Okay, I'm going to remove this because it's irrelevant for this question right now. We know that at 10 seconds, you're left with 0.6 of the original maximum amount. So 0.6 Q naught is equal to Q naught E negative 10 over tau. Okay, so the process that we are undergoing here allows us to determine our tau, okay, because that's the only unknown that we have here. There's Q naught inside this equation, but we know we are going to cross it out because it appears on both sides of the equation. So if you proceed to do your calculation, I believe you can get your tau to be equals to 19.58 seconds. So this is what you get. Okay, if you discharge this capacitor through this resistor for 19.58 seconds, you discharge it for 19.58 seconds, what happens is you see that the charge has already dropped to 0.37 of Q naught. So that's the definition for time constant. For discharging circuit, time constant is the time taken for the charge to decrease until 37% of its maximum value, okay, which is Q naught. Okay, so next question B, the percentage of energy that is left in the capacitor after 10 seconds. Okay, so they are looking for 10 seconds, but now what they're interested in is the energy at that moment. Okay, so what can we know for now? Okay, we know that we can say that the initial U, okay, or the maximum U, you can represent it either using half Q square V square, QV, half QV, okay, or you can use half Q naught square over C naught, or you can use half C naught V naught square. Okay, but let's try to think what is changing during the discharging process, what remain constant during the discharging process. We know that during this discharging process, your Q will be decreasing with time and your V will be decreasing with time as well. Both of them will be decreasing with time. For this second equation here, you know that Q will be definitely decreasing with time, but our capacitance will remain constant. Okay, so this might be a suitable equation to be used because only one thing is changing, the rest remain the same throughout the discharging process. Okay, the third equation, our C is constant, but we know that our voltage here, or potential difference, will be decreasing with time. Okay, because Q decreased, the amount of charge stored decreased, electric field becomes weaker, the potential difference becomes smaller. Okay, so here these two equations might be more suitable than the first equation because you have only one parameter that's changing. Then between this second and third equation, we are probably going to pick the second equation because second equation relates to charge, which is the information we have plenty of. We have plenty of information about. Whereas for V, we don't know a lot of information because mainly what they are talking about here is charge. So we are going to use the second equation over here. Okay, so let's single it out. U naught will be equals to half Q naught squared over C, whereas U will be equals to half Q squared over C. Okay, so this is the situation initial. This is the situation 10 seconds, after 10 seconds, 10 seconds later. Okay, so if you are interested to find the percentage of energy compared to the maximum energy initially, you can do a ratio between these two things here. Okay, so what you can do, you can take U, the new U, divide by the OU, which is the maximum U. Okay, so you can bring in. Okay, so this will be Q squared over 2C. Okay, that's right, clearly. This one will be Q squared over 2C. Okay, so the upper part, or you can say the numerator, there's no naught, whereas the denominator, there's not here because it represents the maximum initial value. Okay, so we know that the capacitance will not change throughout the discharging process. The capacitance only depends on the dielectric, and it depends on the area, and it depends on the distance between the plates. We are not changing any of this, so our capacitance will remain the same throughout the discharging process. So let's write it down. First thing that we know is that C is equals to C naught. Okay, but Q, we know that Q is equals to 0.6 Q naught at 10 seconds. So because this is what we have learned from just now, at 10 seconds, Q has already become 60% of Q naught. Okay, so these two information, we can include it in by substituting it into our equation. So can replace Q over here with 0.6 Q naught squared 2. The C over here, replace it with C naught, that's fine. Then you have Q squared over 2C naught. Q naught squared over 2C naught. Okay, so if you write it like this, I believe you can see that many things can be cancelled out. The Q squared can be cancelled with the Q squared over here. The C naught and the 2 can be cancelled with the 2 C naught over at the bottom. So I believe what's left over here is just 0.6 square. Okay, 0.6 square U over U naught, it will be equals to 0.6 square, so U will be equals to 0.36 of U naught. So what does it mean? Okay, the percentage of energy that is left in the capacitor after 10 seconds, it's only 36% of energy is left in the capacitor. Okay, so what I'd like to say for this question is there's no equation that tells you how the energy decrease with time. Okay, you don't have such an equation. How it decrease with time, there's no such equation. So you have to do it probably through ratio. You know how the Q change with time, so you can relate it between the initial Q and also the final Q. You can relate between the capacitance, which does not change, so you can cross out, and then from there you can find the relationship between the maximum U and also the U after 10 seconds. Okay, so this is our approach to this question, and that's it for this question. Thank you very much.